All right, so today we will be going through the first day of Advent of Code. There is 2 challenges every day, and there's some text here about it. You can get 1 star for each challenge that you solve every day, and the second one is unlocked once you solve the first challenge. So the first challenge is right here. So there is a list, and there's a left side to it and there's a right side to it, and what we want to do is to see how far apart the 2 numbers are, but first we'll have to sort of sort them. So we have to look what is the smallest one on the left side and what is the smallest one on the right side, and then we check the distance from those 2. And here we have an example. So the smallest number on the list is 1, and the smallest number on the right side, so left side is 1, right side is 3, distance or difference is 2. So in this case, that's true. 1 is the smallest one, and then 3 is the smallest one. So the distance between those 2 is 2. Then the next smallest one here is a 2, and the next smallest one here is a 3. So 2 and a 3, that results in a difference of 1. And let's see if it says the same thing. Yeah, 2 and a 3, and it results in a difference of 1. So if the list was this small, we could do it manually and answer it, but we can program it in Python. That's how I'm going to implement it, because it's the easiest and fastest to do. So we will get our test file, which I don't think I can open anymore, but I have it open here. So it is a lot of lines. I don't even know how many. Too many. Actually, we can see it in VS Code. Where is it? Input. And it is a total of 1,000 lines. So we are not going to do this manually, of course, but instead we will be coding it. So what we need to do is to sort the left part of the list and the right part of the list, since there are, well, 2 parts to it, but since they're on the same line, what we will do is I will map it, which will be useful. So first let's do a left list is equal to, well, a list, of course, and then right list is equal to the same list. So now this is where we're going to store the left part of the list and the right part of the list. Now we will open the file. So let's see. Open, what is this called? Input, we can copy the path to it so that we don't have to. We can copy the relative path, not the entire path. Paste it here. This is an easy way to open files if you don't know exactly what path it is in, or you don't want to struggle writing all that. So we open it as a file, and then for, let's say, for each line in the file, we take the right and the left and we map it. So there's a function that is called map, and then it just maps the certain things that we want. And how are we going to map the certain things that we want? Well, we're going to split them and strip them. So we split them wherever we see a space, for example. So they are integers, and then we strip it, and then we split it, just to clean it up a bit. And now, since we have it, we can append them. Left list dot append left, of course. And now it's the same thing for right list. Let's see if autocorrect can help me out. Right. Okay, so now what we've done is we're just adding the left part to another list and the right part to another list, just so it's easier to work with. And the time complexity for this is O of n, because we have to iterate through everything, through every line to be able to do this. Now we have to sort them, and luckily Python has an automatic sort function. Otherwise we would have to implement it ourselves. If this was in C++, merge sort would be good. So let's see, left list dot sort. That's all we have to do in Python. The default sorting algorithm, I think, is timsort in Python, which is a combination between merge sort and insertion sort. It depends on the size and how efficient it's going to make it based on which one it's using. So now we sort the right list, sort. And then, of course, we have to keep a total distance counter, total distance, and we just initialize it to 0. Okay, now what we want to do is to check the difference between the left list and the right list. Since they're already sorted, we can already just check the difference here, check the difference here, check the difference here, and so on. So we just do another for loop. So I'm going to use range here to know how much we should iterate, and we should iterate over the length of the left list. It doesn't really matter because they're both the same size, or they should be at least. And of course, since we're doing a for loop, this is O of n time. And then we do total distance is plus equals to the absolute value. Why do we use the absolute value? Because if we do 10 minus 1, okay, great, that's a 9 distance. But if we do 1 minus 10, that's also 9 distance, but then we get negative 9. And then when we keep adding those numbers, we don't want to add negative numbers, if that makes sense. So we want to only add the absolute value. That's how we get the distance between two different positions. And what are the positions? They're the left list I position, and then the right list I position. And technically you can switch these up. It doesn't really matter because of course we have the absolute value, so we will get the same answer. And lastly, we just want to print the result, and let's see if we run it. Takes a second, and we should get the answer. Sprip. There we go. My bad. Append. Really? Where did I say append? Right list append. Right list append. List object has no attribute. Where did I say append? Oh, I was looking at this one. I was like, what? Where's append? Okay, there we go. Now it should work. Okay, so 1,900,000 something something. So if we look here, I've already submitted it, but it shows what the answer was. So it was the correct answer. So this code works, which is great. And of course, since this is O of n and this is O of n, and then we're just printing, of course, we have to keep in mind the sorting. So since this is using tim sort, which is O of n log n time complexity, then that's what the total time complexity will be. We just take the most significant one. So this is the total time complexity. Total time complexity. So this is part 1, and the total time complexity is n of log n, and this is the easiest way to solve it, and the least complex one in time, because we have to sort it. There's no other way around it. Now, if we go to day 2, not day 2, but part 2, which unlocks after you've done part 1, we will see here. Okay, so now there's something different that they want us to do. So instead, they want us to give a similarity score. So they think that, okay, this list is the first actual one, and this one was whatever interpretation someone made. So there's a bunch of text and lore that you can read about, since this is all Christmas themed, of course. And the similarity score is, okay, you check this line and see what the difference is. And the difference in this case would be, never mind. You check this line, see what number it is, and then you check this line and see how many times that number appears. Sorry. The first number is a 3, and it appears 3 times. So 1, 2, and 3. So that means that we will give it a score of 3 times 3, which is 9. And if it appears again, which it does tell us about here. So for example, this 3 appears again, so we count them again. It also appears 3 times, of course. So we add a 9 again. So we see in the end that we're going to add a 9, a 4, a 0, 0, a 9, and a 9 again. So the easiest way to do this, and the best way for time complexity, in my opinion, would be to just make a dictionary of the right side, because then we would be saying, okay, the number 4 exists once, the number 3 exists once, and then twice, and then 3 times. The number 5 exists once, number 9 exists once. So we just have to iterate once through the entire right side, and then we will get a counter of how many times that number exists. And then when we request it, so okay, I want to know how many times the number 3 exists. We check the dictionary for the number 3, and it exists. Well, it's gonna say 3 times. So that's how we could solve it. Let's try to code it. So once again, we will need the left list and the right list, of course. Actually, let me just take the open file as well. And yeah, we will map the left and right side again, and then append it, of course. So that's to just separate the left side and the right side, so the data is a bit easier to work with. Now, what we will do is that we, instead of a list here, where the hell is, got a different keyboard and I have no idea where, there it is, the curly brackets. So the curly bracket is for dictionary in Python, the square bracket is for list. So now we will do a for loop, so for each number in the right list, which is time complexity of n, because it's a for loop, and right list is just the entire list, so n, of course, how many elements there are. So for each number in the list, if the number is in the right count, so this way, this thing that we're doing here is that we're checking if it already exists here. If it does, then guess what? We should just plus 1 to it. So if we already found number 3, that means that we should just add a 1 to that counter. So that's what we're going to do. So we're going to add right count, and then square brackets n plus equals 1. And then otherwise, we can just say the right count num, right, I call it num, not n, plus equals 1, or equals 1 in this case. So if it didn't exist already, then we create it. And actually, to make it more readable, I can just put an else here, easier to read. So what we're doing here is we're checking through every part of the right side, where is the input. So we're checking, okay, is this number already on the dictionary? No, okay, make it equal to 1, because we just saw it, so it means there's 1 of it. Okay, and then if eventually we go over it again, let's say this is the same one, then we've seen it, and then we just plus 1 to that. So that's what we're doing here. We're just creating the dictionary for the right side, which the left one will need. And now we can make a similarity score, and we say it's 0, and then for num in left list. So this will have time complexity of n as well, of n. And what we're doing here is that we're going to count the score, which, well, they sort of determined. So we will take, let's see, if the number is in the right count. So if we found it, actually, if we didn't find it, then we don't have to add anything, because if the number doesn't exist on the right side, we don't have to add anything to the score, so we don't have to do anything with it. But if it is, then that means that we need to add to the similarity score. So we will add precisely the amount. So in the question it says, okay, you should multiply the original number and how many times it appears. So that's what we will do. We will take num times right count, and then at index num. So this is the count of how many times the number appears. And then we can just print it, print similarity score. Let's see if I misspelled something else again or not. And we have, how much is that? 17 million. And let's see if I got that. Yeah, I got the same answer. Great. So if we think about the time complexity, well, we don't have any sorting actually. We just have this making of a dictionary, which is time complexity of n. we have opening the file, and we have this for loop to actually count everything. So everything is O of n actually. So then guess what? The total time complexity becomes O of, you can either call it 3n, but when you write in time complexity, you just use the significant digit, and we just say it's n, because okay, if it's a bit slower, then nobody really cares. It's just about how efficient the algorithm is as a whole. So if this was n squared, then of course it would be a lot worse than 3n. So we don't really write the number before. So that was the entire challenge. If I haven't mentioned it, which I haven't, everyone can join our private leaderboard. This is the code. I will put it in the description as well. And I think we have some people already, which is great. So yeah, I'll see you guys tomorrow for tomorrow's solution. Have a great holiday.